I hope everybody got the recordings. I saw mail from Sandeep and Raj. They received the recordings. I hope everybody received the recordings probably. If at all you didn't see anything in your inbox, just try once seeing in the spam folder. Probably the mail might have gone there. But yesterday, I think some time back, I shared the video recordings. 2 recordings. This is the third one. So as I was saying, this is the function how we define a simple function. Def keyword, I will say int y as int and x. I will say the condition if x greater than y, return x, else return y. We know that whatever is the last expression in a function, after evaluating that last expression, that value will be returned and from that function. So if we see here, x is the last expression if the condition is true, or y is the last expression if the condition is false in this function. So in either of the case, we are returning an integer. Hence the data type of this function is automatically inferred, or the return data type of this function is automatically inferred based on what is the last value, based on what is the last expression and the value of that expression. So this is how we define a function. Just use the def keyword and the function name and the parameters, and the data types always comes at the last. And if I want to, this is what I will call the function and assign the result to some identifier. So this is a simple way of calling a function. This is a simple way of defining a function, and it is also a simple way of calling a function. But we can call the function in other ways as well. Let's see what is the other way of calling the function. Like function blocks. We can pass a function group of parameters, not a group of parameters, block of expressions while calling the function. Let's say I have defined a function something like this. This is a simple function. The name of the function is format euro, takes a double and does some formatting. We saw earlier F keyword is used to do some formatting. This keyword is used to do some formatting on the string, like, and I can specify %2f, just like we use in printf statements. We do some formatting, the same way this is used. It does some formatting and gives the result. I will just pass like 5.35 something, or 35678. I'll pass a double. It will just format and give me the result. That's all. This is a simple function, and this is a traditional way of calling a function with open bracket and close bracket. But we can also call this function in some different way. A syntax is different with open flower bracket and close flower bracket, and inside that we will have a block of expression. That is also, if you see open flower bracket and close flower bracket, this is also a valid way of calling a function. You may see such functions, a function being called in this form. Format, open flower bracket and close flower bracket, and inside that we are giving a block of expression. This block of expression gets evaluated, like rate is equal to 1.32, and to that rate we are doing some addition and multiplication. After doing this addition and multiplication, whatever value we get, that value will be passed as a parameter. So this is also a valid syntax in Scala. It evaluates all the block of expressions. All block of expressions, after evaluating whatever value we get, that value will be sent to will be passed as a parameter. So just to understand the syntax, that these are also the way of calling a function. So any questions still here? Yeah, if there are no questions, we'll move ahead and look at some more functions called nested function. I think nested function is known in some other languages as well. The most commonly used nested function is, anybody any idea on where is nested function more commonly used? Which language uses nested function? Yeah, anybody like
Python.
Python? Python may use, but most commonly, a lot of times we use it there. It's a common thing in that language, and it is also the most popular, most widely used functional programming language. It is also most widely used functional programming language.
Haskell.
Uh, Haskell is a functional programming language, but not most widely used. It is actually JavaScript. JavaScript is the most widely used functional programming language, and you will see lot of lot of uh, nested functions inside there. Any event comes, a nested function is defined there. The click of a mouse, all those things. Yeah, Ruby also
Okay.
has, because Ruby also uses this higher order functions. There also you can be seen, but most widely is the JavaScript. Yeah, we'll see what is the nested function here. It's similarly defining a function inside a function. There is no big deal here. Defining just a function inside a function is called a nested function. And what is the use of defining a function inside the function? One thing is, we are making that function private. One thing is, we don't allow this implementation to be known to the outside world or any other program. It doesn't, it is not allowed to be seen on the outside world. Any other program cannot access this function. This is a nested function which is defined inside one more function, and it will only be accessible from the outside function only. Within this function only this will be accessible. If you see something like a private, that is the use of this. We don't allow access from outside world. And one more thing is, we can always reuse the existing code here. We are reusing. What we are doing here is, the problem is, we are trying to compute maximum of 3 elements. We are trying to compute maximum of 3 elements. Maximum of 3 elements, we already seen max of 2 elements. We saw that in this fashion, which takes int, two integers, and we just said, if x is greater than y, return x, else return y. We just said this. But if you want to compute a max of 3 elements, if I say int x y again integer, and z one more parameter. So how could we do this? This could be done, just a second. Good morning, Sharat, and good morning, Raghu. We were just starting with the functions here. Here we are trying to see the nested function. So we saw a function that computes maximum of 2. If I want to compute maximum of 3, I have to write a lot of if-else condition. I have to write lot of if-else condition. If x greater than y and y is greater than z, just say return x. Again, if y is greater than x and y is greater than z, return y. Again, z is greater than y x and x is greater than y, again return z. So you need to have multiple if condition to compute the maximum of 3 elements. But what we can do is we can reuse existing maximum of 2 elements and compute maximum of the 3 elements in this fashion. I would say I will define a function here. This function will be internal to this function. Define max. I will say here, let's take a int b integer is equal to, again, if a is greater than b, return b, else return, what is happening? Return a, else return b. And I have to call this function inside this outer function only. We cannot call it from anywhere else because I said it will be a private function to this function. So since I want to compute max of 3, I will say max of x, comma, again I will call max of y, comma, z. First it will compute whatever parameters we pass. Suppose I pass max of 1, comma, 5, comma, 6. First 5, comma, 6, x is 1, y is 5. We are calling this function. These two functions will be called from here. 5, comma, 6. It will compute the maximum of 5, comma, 6. Obviously we will get 6 here. Again 1, comma, 6 maximum will be computed. Finally we'll get 6 will be returned here. This is a simple function here. We are just trying to understand the nested functionality of a Scala programming. Nested functionality of a Scala programming. Obviously finally again it will check max of 5, comma, 6, whichever, sorry, 1, comma, 6, and 6 will be returned from the max. So this is our nested function. So here the nested function here is, one is the private function and one more is we are reusing it and we are not giving the implementation to the outside world. We'll just copy and paste this code. So I can call this function max of 5, comma, 6, comma, 7. Obviously we'll get the 7 as the maximum of all the 3 integers and we have reused something else here. Maximum of 2 integers. But if I try to give only 2 elements, what will I get? If I try to call this function, probably with this function we have already defined, it will be outside this function, it will be called actually. What I will do is I will recopy it, maximum of 3. So now if I say max of 5, 6, what will I get? Obviously I should get a error. The compiler doesn't even know that this function exists. It says not enough arguments for method max. The compiler thinks that we are trying to call this function and we have missed the last parameter. We have missed one of the parameters in this function. The compiler doesn't even know that this function exists outside this outer function. So hence it becomes a private function here. I hope the nested function concept was clear here. Any questions here? If there are no questions, let's move ahead with these. These are also new, not a new thing here, variable number of arguments, but this is the syntax how we represent to specify variable number of arguments. If you want to pass variable number of arguments, so this is the syntax. After the data type, just use a star, so we can make this function as a variable number of arguments function. We can pass no arguments to this. We can pass multiple arguments to this. Yeah, we can pass when we say star here, we can call this function with variable number of arguments. I can say sum of, I need not pass any parameter at all. I need not, I can pass only one parameter. I can pass more than one parameters or any number of parameters. So this is how we pass a variable number of arguments. So it is also available in other programming languages as well. We are just seeing how it is done here. Just use a stars symbol at the end of the data type. These are all the simple things. There is a new concept in Scala now. This is the new thing that we will be seeing in Scala, that is called parameter groups. This is called parameter groups here. So what is parameter group? So if I say, I will say a function called product. I will pass x integer, y as one more integer, and I will just say x star y. X star y, I will get the result. This is a traditional way of defining a function, and the traditional way of calling the function is just this product. I will say 4, 5. It will multiply it and give the result. But there is one more way of defining a function in Scala, that is called currying. It is usually called currying. So what is currying here? Currying is nothing but we'll have multiple parameter groups. We'll have multiple parameter groups here. So how do we define this? We can call as a parameter group. This will call as a parameter group which contains two parameters, but it is a single parameter group, such that we can have in same way we can have multiple parameter groups. I can define a function product. I will say x int, and this is our y as int. So this is also a valid syntax. The definition remains the same here. This is also a valid syntax. This is called currying, and this is a currying means multiple parameter groups. We are having two parameter groups here. The first parameter groups contains one parameter. The second parameter group contains one parameter. So this concept is called, this is not a concept, we can say a new syntax that we have seen in Scala. And what is the use of this multiple parameter group? As of now, we can just imagine that we are grouping certain properties or certain parameters of the same category into one group. Just say that when we have, if I am saying def product and I will say x integer, this is the first parameter group. I will say y int, this is the second parameter group, and I will just say x star y. So the use of this currying function is, usually it is called currying multiple parameter groups. The use of this is, as of now we still need to learn higher order function. We have to learn implicits, higher order function and implicits. Once we understand these two concepts can be used with currying. The currying concept will make sense in that case. As of till then, you can just imagine that we are separating certain parameters of the same group, same category, probably x, and we can have multiple such things like define, I will say function f1, I will say x integer, x int, I can have y int, and I can have z double. I'm giving a simple example here, and a double again. So just you want to differentiate or categorize certain parameters of the same property, here. This is also not a valid use case, or it is like an understatement for currying. It is an understatement because currying is much more than this. For that we need to understand higher order functions and implicits. Otherwise, as of now, you can just imagine that we are differentiating or separating certain parameters which have same properties, or grouping together certain parameters which have same properties. That's what we can imagine here. But we'll see what is the use case of curry. So any questions here? Till here, any questions on currying parameter groups? Or anything else as well is also good. Any questions irrespective of what we are covering in this topic? Anything else should also be good enough. Harsha, you are able to follow, right?
Yeah, Pramod.
Okay. Uh, Next we'll see, if there are no questions, we'll move ahead with the next topic, that is type parameters. Type parameters is nothing but making your function generic. Making your function generic here. So what we want to be, let's say I'm defining a function identity here, and I will pass x as string, and what I will return is, I will just return a yes here. This is a simple function which takes a string. A simple function that takes a string and just returns that string, that's all. It doesn't do anything with that string, the input parameter. So the way we call this function is, I will call this function saying it is a Scala. take this function and do it as a Scala here. So can I call this function with integer? Can I call this function with integer? Obviously, it gives an error saying that integer found and required is a string, because we had defined this function to take an string, but we are passing an integer. Obviously, it will give a type mismatch error. Similarly, if we try to give some other data type here, like I'm passing a double value, even here also it will try to give an error, because we had defined that function to take only string and it obeys by that rule. But what if we want to pass any data type? We want to pass here any kind of a data type, irrespective of, I mean to say, it should not be limited to only string here. I want it to take any parameter. So how do we achieve that? This is where the type parameter comes into picture. This is where the type parameter, the way we achieve the type parameter is, I will give the same function here. The type parameter is specified in the square brackets as some parameter name, usually a capital letter, and I will say x is of type A. X is of type A, and I will return just x here. So this is how we define a type parameter. Type parameter is nothing but like we pass a value for a normal parameter. Similarly, we pass a data type for the type parameter. We pass the data type for a type parameter. So we call this function in this fashion. We call this saying, I can say int, I can say pass 10 as the parameter here. Similarly, I will passing double, I can say 10.5 as the parameter, and it works. So I will say I will pass a parameter as a string. So I can pass a string here. So the type parameters is specified in this fashion. It is specified in this fashion. But even this is redundant actually. Whenever we call this function, even this becomes redundant, because we know that by the value itself, the data type will be automatically determined. The compiler will automatically infer the data type based on the value that we are passing. So we can say, we can just skip those things and just say identity of 10. It should work. I can just skip everything and just say identity of 10.6, which is a double. It works fine. Similarly, I can skip for string as well and pass it as it is. So it should work. So this is a type parameter. Type parameter use case is whenever you are developing any API or a library or a framework, you want that API to be very generic. This is where the type parameters will be used. So in Scala as well as in Spark, we will see lot of type parameters. I think it is the same thing as Java generics. Let's not go back and compare to Java generics here. Let's stick with the Scala itself, because I know few people may not be from the background of Java. Let's say it is a generic API. Whenever you are writing your own API, when you want to expose your API to a third party or to the other team, you want to make your API very generic so that it takes any kinds of a data. It is not restricted to a certain data type, but it should take any kind of a data type. That's where you write your uh, generic kind of a function, type parameters kind of a function. So any questions here on type parameters? So you can imagine type parameters in this fashion. So if you see, these are called as values. I will say 2.5. I will say a scala here. These are all called as values. Like we assign a, we will pass these values for this parameter, or we give a name to these values. We pass a values. Our values are associated with some identifier. Similarly, we can say this is a type parameter. Just like this is a value parameter, this is a type parameter. And as we pass different values for a parameter, we can pass different data type for this type parameter. We can pass double, we can pass string, we can pass boolean, anything. We can pass a custom object, anything can be passed here. So we can think of it as a data type. Like we have just a comparison here. Like we have value parameter where we pass different values to that. Similarly, we have a type parameters where you on the fly we pass the data types here. So it is only convention to use a capital letter. It is so that we don't get confused with the normal identifiers. It is a convention to use the capital letters. We will sometimes we will also see double character capital letters. It is only a convention, and we need to follow such convention. Otherwise, we'll get confused with normal identifier or normal parameter and the type parameter. So I can also define in the other way also. I can say, I can just say here anything. Just like the parameter name, I can give anything here. X will be of the type ABC. It works, but adds lot of confusion. I can give anything here. SSS, I can say SSS. It adds confusion. Always try to have it, there is a question here. Let's see what is the question. The question says add T comma B print expected but found. Just give, I'll just try to give it in this fashion. Add, it is T comma B, and say X is equal to T, Y equal to B. Now try here, println, I will say double quotes you are giving, they are saying X plus Y, font value add. So this should work here. I think you have given double square brackets, two square brackets. This is not the syntax. I think you have given this syntax. So the syntax is like this: multiple parameters, multiple type parameters, just separated by
Okay.
comma.
Pramod, I have seen like that syntax. That's why somewhere. So I tried it like this.
So this
In square
syntax,
bracket T. Yes, yes.
okay,
Uh, this kind like add a T and next generates what will be like this.
oh is it? But it clearly
Mm.
says that the error is expected something else, and open bracket
Okay,
is
okay.
given there.
Whenever I will get, then I will ping
Yeah,
you.
yeah, please, please. Just
Okay,
send me that code, piece of code, we will check it out. But this is
okay,
how we specify multiple type parameters. Thanks for coming up with this question. It
okay,
made, like, we are able to see how to specify multiple type parameters. Just use a comma separated type parameters. So X is of the type T, Y is of the type B. Type B means any generic data type. Any generic data type here. Here T and B could be the same data type, and it could be of different data type as well. When we are saying add T comma B, and we are saying X as T comma Y as B, it means that T may be equal to B, or T may not be equal to B. This is obvious by seeing this. This looks obvious because we are saying that these two are different data types. But this is also valid. It can be equal to B also, because T could also be integer, B could also be integer here. So I can say like add 5 comma 6. So it concatenates 5 comma 6 here. Both are integer in this case. So it is nothing but it can take any type parameters. Any type parameters. So any questions here on type parameters? It is just a convention that we have to use capital letters, because we can differentiate it with the normal value parameters, not to get confused with other parameters. We can also write the same thing with in this fashion. Anything. This is also valid syntax. It just says it is a type parameter, but this has to be used here. It is just a convenience. It's just a convenience to use some capital letters, but you can give, like we can give any any name for our value parameter, we can give any name for our type parameter, but always try to make it as a single character with capital letter, single character capital letter. At the max I have seen double character capital letters. Sometimes they are using double characters. I hope the type parameters was clear. This is where you want to give your API to the third party and make your API more and more generic to any kind of a data. Any questions here? Venkat, Sukesh, Sharat, Raghu, any questions? Okay, Naresh, no questions. Okay, I hope we are everybody. I'm able to convey things properly, and hope everybody is in the same page. Okay. So this is how we specify the type parameters. Yeah, I think methods and operators we did see in the last session based on the question asked by Ram. That's This is what I was earlier saying him to hold that question for a minute, because we will be covering that. That's what we mean here, because Scala is a pure object oriented program. That's what we said. I will just try to repeat those things. Scala is a pure object oriented It means when we say x equal to 10, x is an object of type integer class. Similarly, when I say val y equal to 2.5, it means y is also an object of double type, of the type double class. All are objects in Scala. Anything that we create is an object in Scala. So we can say, when we say x plus y, val z equal to x plus y, when we say this, it is nothing but x is an object on that plus method is called, and to which y is passed as a parameter. Y is passed as a parameter. This is what we saw last time. So these two are two different syntaxes, which is our valid syntax. This also is a valid syntax. Not only does it apply on the arithmetic operators kind of a methods, it applies on any method and any object. It not just applies on the arithmetic kinds of methods, but it will apply to any methods also. So we can have a generic rule as, for this syntax, the generic rule is object, we have space, then method, then we have space, then after the space we pass the parameter. But in this case, how it looks like: object, we have a dot, then the method, and to which we are passing the parameter. The functionality of both the things is same, but this syntax is also valid, this syntax is also valid. Object space method space parameter, this is a valid syntax. This is also valid syntax. So we had seen this thing in the last session, just doing a recap, that's all. So I will just move ahead with this because we have already seen. If you see, compare. Compare is a method that is being called object compare method, and this is the parameter that is being passed to that compare method. So instead of like d dot compare and passing a parameter in the open bracket and close bracket, we are just giving in this fashion, and this is also valid syntax in Scala. So let's move on with this, and let's see some more advanced things as well as very important things from the perspective of uh, Yanaresh. Oh, okay. You want to repeat it again? 1 second. No problem. Yeah, when I said x equal to 10, it means x is an object. That's what we mean. Scala is a pure object-oriented program. Anything that we create in Scala is an object. That's why we say it's a pure object-oriented program. Is a object. So when I say val x equal to 10, x is an object of integer class. When I say y is equal to 2.5, it is also an object of double. It is also an object. Everything is an object. And whenever we say val z equal to x plus y, what does it mean actually? Since this is an object, there does not exist any operator in Scala. There does not exist any operator in Scala. Everything is a symbol. A symbol is being used as a method name, method on the class, method on the object. These are only the symbols, and these are methods on this object. So integer class has a method plus, to which y will be passed as a parameter. It means integer class object we are getting. On this object we are calling plus method, and we are passing y as a parameter here. So we can look into here saying that I will say val x equal to 20. I will say val y is equal to 30. When I say this, both are objects, and when I say val z equal to x plus y, actually internally what happens, val z equal to it is x dot, the plus method on that x will be called. On the x object, the plus method will be called, and y will be passed as a parameter here. The y will be passed as a parameter. So this is how it works. Internally it is only a method call. So this syntax, if you see, is a totally different. This syntax, if you see, it's a totally different. So for this syntax, we can have a generic rule. This syntax, we can say that it is nothing but, if we compare this, we know that this is x is the object on which we are calling plus method, and we are passing y as the parameter. Y as the parameter where it does. So object, on that we are calling the method using the dot reference, and we are passing a parameter. The same thing can be written in this syntax as well. We have an object, then we have some space, then we have the method, then we have some space. So it is not only restricted to arithmetic operations, it is also valid for other things as well. I will say is equal to Scala. So I will then check like val s1, I will say, or b equal to s dot contains, I will say la. Whether this contains method is on this object. On this object, we are calling this contains method. It checks whether this object contains LA. Whether this object contains LA. Obviously, it contains LA because LA is there in Scala. So it will return true here. It will return true. The same thing can be given in the form of another syntax in this fashion. S space I can give in this syntax. This is also a valid syntax because if we are comparing here, it, it is the same thing. Object, and we have method here contains, and we have the object, one more object being passed as a parameter similar to this. This is the object, a method on that object, and this is the parameter that is being passed as a this is the object which is being passed as a parameter. So both are valid syntax here. I hope Naresh you got it here, what we are trying to say. If you see such things, it is nothing but a method object, and its method is being called, and a parameter is being passed to that method. Naresh, I hope you got it right. Yeah. So next we'll learn a bit of some more concepts here, which is called, we will finally boil down to higher order functions. We will finally boil down to higher order function, but before that we need to understand some more concepts. So that is called, functions are called first class citizens in Scala. It is just a statement here. Functions are called first class citizens. We have to, what does that mean actually, and what it will drive to finally what the result that we will get by this, that we have to see here. So when I say functions are first class citizen, what it means is, again it goes back to Scala as a pure object oriented program. object-oriented program. So what is that mean here? Anything that we create in Scala is an object. We saw that in the last example. Whatever x we created was an object. Similarly, the functions also that we created in our previous examples, like we defined a function max, which takes integer, two integers, and it checks if x greater than y, return x, else y. Actually, this is also an object. That's what we mean. Scala is a pure object-oriented program. It means anything that we create in Scala is an object. Even the functions are also object. We need not go internally how they are represented. There is something called function class. There is something called class function. So all these things are object of that function. Let's not worry about those things, because if we go more internals, we may get confused. Let's let's be let's let's say that anything that we create is an object. Even the function is also an object. So when a function is an object, whatever we can do with an object, all those things we can do with the function also. So what all we can do with the object? An object can be assigned some value. Like we can say x equal to 10. We are assigning some value here. What else? An object can be assigned to some other object. Just like, well, y equal to x. One object is being assigned to another object. One object is being assigned to another object. We can also pass an object as a parameter to a function. So I can say, like, this is that one thing. X and Y are being passed as a parameter, and X and Y are objects. So all these things we can do with the object. Similarly, we can return an object from a function. Return an object from a function. All these things we can do with the object. And we said that function is also an object. Obviously, we can be able to do, we should be able to assign a value to a function. We should be able to assign a value to a function, because function is also an object. We should be able to assign a function to another function. We should be able to assign a function to another function, because function is a object. We should be able to pass a function to another function. We should be able to pass, because function is also object. We should be able to return a function from a function. We should be able to return a function from a function. Because of these properties, functions are called first class citizens in Scala. Whatever we can do with objects, all those things we can do with the functions as well, because functions are also objects, and that is because Scala is a pure object oriented program. uh, can you give an example of a function return from a function? Okay, that's a good question. We can just say, first we'll go through one by one. Probably directly going to this would not be a. I will give an example. Yeah, that means a sharat is able to follow the whole concept of function being passed as a parameter. That's great to know. Seems like other three things are seems to be simple for Sharat. Yeah, great. That's great. So now we'll see. The more important thing here is this third point. This is very important. The third point is very important, where we pass a function as a parameter to a function. So I will try to give some, we'll try to learn some small concepts. Finally, we will arrive at this concept. Finally, we will arrive at this concept. Before that, we will go through small concepts. Probably you have to keep those things in mind. Initially, it may not make sense, but you need to keep those in mind. Finally, we'll arrive at these things and combine all those small concepts that we learn. The small concepts that we learn that will be used. But initially, just hold on to when we learn all the new things. So here what I am saying, I will define a function called doubler, and it takes an integer and it doubles the integer and returns the value. That's simple. This is a traditional way of defining a function. Just pass a parameter and return, double the value and return the value. Double it and return. This is a traditional way of defining a function, and the traditional way of calling the function also, we know that. We can just call doubler of 5 or 4. It will just return double the value and give it to us. This is a traditional way. Let's take how we define an object. Now we are trying to say that functions are also object. So earlier how we defined an object, we just said val x. I will also specify this time data type just for the understanding purpose. This is how we defined an object. So we should be able to define a function in the same way. Instead of defining the function in this way, we should be able to define a function in this way, because we are saying function is also an object. Let's try to define a function in this way. Val, I will say, I will define a function object for this function. So let's define a function object here, object. I will say my double. After my double, if you see, we have to specify the data type, like we are specifying the data type for a normal object. So what will be the data type of a function? So the data type of a function will be the input data type and the return data type. The way it is represented is input data type and the return data type. So if I will specify input data type as integer, and return data type is also integer. So this is how we represent a data type of a function. These are all, whatever is here, it will be the input data type. Then we have an arrow mark and then the return data type. If we are passing multiple parameters, if we are defining a function object which takes multiple parameters, we need to have multiple parameter data types, all the parameters data types. As I was saying, I'm trying to create a function object for this function. We are trying to create a function object for this function. So if we see, the input data type is an integer and the return data type is also an integer. Hence we are defining input data type an integer and return data type is also integer. So to this I can assign a value and that value is nothing but doubler. I am assigning this function to this function object. I am not calling this function. This function is not being called here. I am just assigning this function to this function object. So the data type of this should match the data type of this, as if we are specifying an integer, it has to be an integer here. If you are assigning a value integer, it has to be a data type is also integer. In a similar way, if you are assigning some function, that function's data type should match this data type. Otherwise, we'll get a error. So this is how we create a function object. So this is how we create a function object. So I can call this function object now. I can say pass 5, it will double it and give it. I will pass 6, it will double it and give it. I can assign this to my double 2 equal to my double. I can say val z equal to my double 2. I can just assign one object to another object. All these are function objects now. All these are function objects. I can pass any value to this identifier z, and this identifier z is nothing but a function object. It will double it and give the result. So this is how we create a function object. This is how we create a function object. Here is a question: how to specify multiple parameters? So let's say that's a good question. Let's take it here itself. Let's say I have a function like I will say val product. Let's say define. First I will show how it is defined. Define product x int y int, and I will say x star y. I will say x star y. If I want to create a function object of such function, I have to say val product my product. I will say I will give some other name, my product. I will say it takes two parameters, just specify the data type of those two parameters. And the return type is also, if you see, return type is also integer, specify return type as integer. And assign the product here. Assign the product. This is how we create a multiple parameter function object. This is a multiple parameter function object. So I can call this my product now. I can pass 5, 6. It will multiply it and give the result. So this is how we specify or create a function object. I hope that was clear, Naresh. Yeah, now what we'll do is we will try to get rid of this intermediate step. We need not create a function, then assign that function to a function product. Sorry, then assign it to a function object. We can directly create a function object by assigning a value to that. Let's say we'll compare it with this. So usually what we say here is, suppose we have 10, we have 2.5, we have Scala here. So these are called as values. These are called as values. And also it is called as literals. These are called as values or literals. Literals nothing but values in the sense we can assign these to some value parameters, to some identifiers or some parameters. We can assign these values to these things, some identifier or some value parameter. So literals, what we can say about literals is literals are nothing but values without a name. Literals are nothing but values without any name associated with that is called as literal. Similarly, we can say literals or values are nothing but there is no name for that. No name for that. Similarly, we can say what are a function literal. What is function literal? Function literal is also nothing but a function without the name. A function without a name, let's say I define a function product and I say x as integer, comma y again integer, then I will say equal to x star y. When I say this, what is a function literal here? Function literal is nothing but everything except the name of the function. This is called function literal. This is called function literal or the value. Function value we can say. We can compare, not a value, it's nobody says it as a value. I am just trying to compare. Just like we have literals or values here, this is called function literal. So like we assign val x equal to 10, as we assign just a value to a object, like we assign a value to an object, we can assign a function literal to an object. We can only assign a function literal to an object. I can say my product is an object and I can say just assign x int comma y int, and instead of equal to sign, the only difference when we are doing a function object is x star y. So like we are assigning a value or a literal to a identifier or for an object. Similarly for this object we are assigning this function literal or a function value we can say. So we got rid of this function definition altogether. That this definition is not at all required. We can directly use the function literal and assign it to my product. So we are skipping a step here. We are skipping a step here. This is also valid way. So I can say I can define a function val my tripler. It will triple the value and give it. So I can say it will take a parameter and I will say x star 3. So if we see this, this is nothing but our function literal, a function without a name of the function. So I skipped, we just skipped this thing. Probably I can say tripler, define tripler, which takes int and it returns x star 3. We skipped defining this function and then assigning this function to this function object. We just skipped that. We directly gave the function object here. We directly give the literal of the function, and what we mean by the literal of the function, the literal of the function is nothing but the everything or the function body parameters except the name. Without a name it is called a function literal. So we just skipped this statement altogether or this function altogether. So I can say my tripler and I can pass some value and it will triple it and give the result. I hope you got how we skipped one step. We just made a more compact here. Unnecessarily, we did not have to define a function, then assign it to a tripler. We can directly use the function literal and get the result. If you see, the data type is automatically inferred here. The data type is automatically inferred, saying that it takes an integer and its return type is also an integer. So this is how we create one more way of creating a function object without defining a function and assigning that function to this. I hope things were clear here, how we use the function literal to create a function object. So this is our function object. So just keep these things in mind, because these things will help on, we are still not using these things. Probably in your mind it may be going, why we are doing all these things. Just keep these things in mind as of now. Just hold on to that question. We will come to what bigger problem it solves. What is the bigger problem it will come to solve. Again, I will try to do one more shortcut here, because we will be using this shortcut again. I will say my tripler. In this case, I have to specify the data type. I will say int. Here, I can say underscore star 3. Intuitively, just you need to remember these things. There is no internal logic that we can deduce for this, but you have to just remember this. It means we can skip the parameter name at all. We can skip the name of the parameter altogether. That can be replaced with underscore. Here underscore means the parameter that is being passed to this function object. If we are passing multiple parameters, so multiple underscores can be given, where the first underscore will map to the first parameter, second underscore will map to the second parameter, and third underscore will map to the third parameter, and it will go on. So this is also one more shortcut where we are getting rid of passing a parameter name. We can just use a underscore. As I was saying earlier, based on where the underscore is being used, the definition or the meaning of the underscore will differ. So here it is nothing but it is a placeholder for the parameter that we are passing. So here if I give my tripler, okay, I have defined multiple times. Oh, okay. I'll just say tripler. So I can call this my tripler, and I can pass 5 or 6, anything. It will triple the result and give it to us. Here underscore is nothing but the parameter 6 that is being passed. Underscore is nothing but parameter 6. If we have multiple parameters like Naresh asked, like I have in this fashion, so in that case how I do is I will just say underscore star underscore, where first underscore will be the first parameter, second underscore will be the second parameter. So this is how it works. If we have a multiple parameters. So I will say my product, and I will say 5 comma 6. So 5 is the first underscore. That ordering will be maintained. First underscore will be 5 and the second underscore will be the 6. So it will multiply the result and give the result. Just hold on to these concepts now. We created an object, function object, by normally assigning a function. We created a function object through the literal of the function so that we can skip the definition of the function altogether. Then we made one more shortcut. We skipped the parameter name itself. We skipped the parameter name itself and just use the underscore instead of the parameter name. So keeping all these things together, we will go into the third point, which is passing a function as a parameter to a function. This is very important now. Now we will be discussing passing a function as a parameter to another function. So that itself is called a higher order functions, or these things can be called as, I think, I don't know, Ram asked what are monads. I am not I'm not much sure about that jargon to which it applies. Probably it is a function literal. Function being passed, literal being passed as a function to another function. Function being passed as a parameter to another function, we call it as a higher order function. Probably it is also called as a monads. I'm not sure on the jargon, but everything boils down to these concepts itself. It's the same concept, passing a function as a parameter to a function. So we will learn this now. Passing function as a parameter to a function. We are still not knowing, we still don't know what is the possible use case of these things. Just hold on to that question again, because we'll see what is the possible use case of these things. Why do we need all these complexities here? So we'll come to those points one by one. So first we'll try to use higher order functions. Higher order functions are nothing but passing a function as a parameter to another function. So I will just define a simple function here, a higher order function, not a simple, but a simple higher order function. I will say string ops. I will say string ops. I will say x as a string. First parameter is a string, and second parameter I will say I want to pass a function. The second parameter to this I want to pass a function. Like we specify the data type for a normal parameter, we need to also specify the data type for the function parameter. So let's say I will define the input data type is string, and the return data type is also string. Let's say I define this as the data type of the function. Like we specify the data type of a simple parameter, we also need to specify the data type of a function parameter, function object parameter. So what we am doing here? What is the definition of this higher order function now? The definition of higher order function is nothing but I will check if s is not equal to null. If s is not equal to null, whatever function I pass as a parameter, that function will be called. I will call that function here. I will call this function. The function will be passed as a parameter, some function. It can be any function that we can pass as a parameter as function object. As a function object, we can pass any object here which is of the type this type. But when we call that function, we should pass a string because we have defined it to receive a string. We have defined the data type to receive as a string. Hence, we have to pass a string to this function whenever we are calling this function. So obviously, I have to pass some string. We know that s is a string. I will just pass s to this function. I'm calling that function and I'm passing s here. Else what I will do, I will just return a yes. Nothing. It is a simple function, simple higher order function that takes a function, and that function is called inside the body of this function. This function is being called here. So I'll just view this. So what function I can pass to this? What function I can pass to this? I can pass a function which matches this data type. So let's say I define one more function, convert to uppercase. I'm defining one more function, convert to uppercase, takes a string, and it just says there is a method called to uppercase. On a string, there is a method called to uppercase. I'll just call that function. So what this function will do, this function will take a parameter and it will convert into uppercase and it will result. So I can say, I can call this function in this fashion. It's a simple function where we pass Java as a function, Java as a parameter. It will convert into uppercase and it will return that result. So if you see the data type of this function, it takes a string and it returns a string. It takes a string and returns a string which matches the function that can be passed as a parameter to this function. Here also it takes a string and we have defined it as to return a string. Takes a string. Obviously what we can do is we can pass this function as a parameter to this function. We can pass this function as a parameter to this function. So let's call this function now. Let's call this function and we pass this as a parameter. So it will, what happened? Not enough parameter. Obviously, because we skipped the first parameter here, and I will say Scala is the first parameter. First parameter is a simple int string. Second parameter is a function. Hence, we are passing this function. So it will just convert it into a capital uppercase and it will return it because that's the definition. Yes, string scala is not null. Yes is string scala here. Hence it is not null. Our convert to uppercase method is being called, sorry, function is being called here. This function is being called here because that's the one we are passing as a parameter and that is the one being called. And to which we are passing string scala as a parameter. Obviously it will convert into uppercase and it will return. So we also said that we need not define the function at all. We need not define a function. If you go back to our previous example, we said that we can directly use the literal of the function. We need not define the function at all. This is our literal of the function. I can directly use this. I can directly use this, but only difference is an arrow mark is a separation here. So I can directly use the literal of the function in this fashion. It gives the same result. We also know that the data type is automatically inferred by a compiler. So we don't have to specify the data type as well. So it works as this. So we also saw that parameter need not be passed. We can directly use the underscore here. So we can skip the underscore as well and we can keep it in this fashion. So we have made more and more compact. The code has been from defining a function, we have just used the logic here. We just use the logic of that definition of the function. We made a more shortcut. If you will see a lot of such code in Scala or in Spark or Scala, you will see a lot of such code where underscore is being used or the logic, just the logic is being passed as a parameter to a higher order function. So what is the use of being passing a logic? We'll see that. We will see that. So I hope you got how we came to this point. But now, what is the use of this? Why we are writing a higher order function? Why such a complex thing is being used here? Why we are writing? We could have just used convert to uppercase. We could have called that function. It would have converted to the uppercase. But why we are writing a higher order function that takes a parameter? What is the use of this? We can directly write all simple function and achieve everything. Why we need a higher order function? So the main use here is, again, don't repeat yourself. The dry concept, don't repeat yourself, DRY. So where you reduce the number of lines of code and you don't repeat it again and again. Let's say assume I have a array here. I have an array saying red, blue. I will say red. I will say yellow. I will say green. So I have an array. I will ask you to write a program to sort the array in ascending order. Obviously, you will write a program to sort it in the ascending order. Next, I will say write a program to sort the array in the descending order. Obviously, you will write one more function to one more program to sort the data in the descending order. Finally, next I will ask write a program to sort the array by the first element of the string, first character of the string. First character like B, red, R, B, R, Y, and green. Obviously B first should come first, then G, then R, then yellow. So you have to write one more program to sort by the first character of the string. Again, ascending and descending I will ask. Again I will ask again and again two more programs you have to write. So then I may ask sort by last character of the string. Again in ascending and descending order. Again two more programs you have to write. Then I will ask write a program to sort the array by the length of the string. Length of the string. Length of the string means this length is 3, this length is 4, this length is 6, this length is 5. Obviously red should come first, blue should come second, green should come third, and yellow should come last. Again I will say in the ascending and descending order. Again two more programs you have to write. So I can go on with certain problem statements, and every time a new program has to be written. What if we could write only one program? Only one program, rest you can pass as a logic. Rest of the things we could pass as a logic. So this is where that higher order functions comes into picture. Where we define one program, rest of the things can be passed as a logic. We will write only one sort algorithm or a sort function. Rest of the logics based on how you want to sort the array, those things will be passed as a logic. So this is the main use of higher order function, reduce the number of lines of code and make it more and more compact. Instead of writing 20-30 programs, just write a single program. Just write that reduces the code maintenance. More the code means more the bugs. More the bugs means more the maintenance. Similarly, less the code means less bugs. Less bugs means less the maintenance. And obviously companies would prefer that. Companies would prefer that. Hence we have a higher order function. So here what I can say, if you see, I can just pass one more logic here saying reverse. I'll just pass one more logic here, just say reverse. It will just reverse it and give the result. I did not have to define a new function here. I did not have to define a new function altogether. I had to just specify underscore reverse, the logic, underscore uppercase, underscore lowercase. Everything could be done there. If I pass something like this, I will say scala. I can say to lowercase. It will convert into lowercase and return the result. I just gave one function. Rest of the things are just as logics. So obviously I am saving lot of code maintenance here. So I hope you got the understanding behind what is a higher order function here. So this concept is very important because Scala has lot of higher order function. It will be very rare that you yourself will be writing a higher order function in this fashion. It will be very rare that you yourself will be writing such kind of a function, but most of the time we will be using the higher order function here. By passing the logic to that higher order function, we will be using our higher order function. Scala has a lot of higher order function. Similarly, Spark also has lot of higher order functions. We have to just get used to using those higher order functions. So I hope the higher order function was clear here. Yes. And the problem that it solves. What is the use case of the higher order function? Yeah, I have one more example on that to give a some more highlights or to throw some light on higher order function. Let me define one more function like operations. In this case, I will be passing two parameters, int, and I will say, sorry, and the third parameter I will be passing as a function here, and that function takes again two parameters. So this is the data type how we specify a function of two parameters, which takes two parameters, and we are also saying that I will be passing I will be returning an integer. It takes two integers and it returns an integer. And what I will do, I will keep the higher order function very simple. I will call the function that is being passed, and I will pass x and y because x is also integer, y is also integer, and this function takes two integers. Obviously I can call that function by passing x and y because x and y are also integer. I will keep that operations very simple now. So now what I can do is I can define a function called sum. So what it will do, it will take two integers. I will say y as one more integer, and I will say x plus y. I'll define a simple function called a sum which takes two integers and it will add both the integers. If you see the data type of this function, the data type of this function is it takes two integer and it also returns an integer because addition of two integers is always an integer. Hence, if you see this data type matches this data type. This data type matches this data type. Obviously, we can pass this function as a parameter to this function. Obviously, I can say operations. I will say 5 comma or 4 comma 7 is being passed as a parameter. The third parameter is the sum function. So this is how it will add the result and give the result. Sum function will be called inside this function in this fashion. So I also know that I can get rid of all those things. I can just use the function literal, then I can also skip the data type, and also I can skip the parameter. I can just say underscore plus underscore, where first underscore is the first parameter, second underscore is the second parameter, which is nothing but x plus 5. The logic has been passed here in this fashion. So if I want to multiply two things, I will just say multiplication. I need not define one more function as product. We got rid of that step. I just say multiplication. If I want to subtract, I will just say subtract. I need not specify one more function here as a subtract. I can also use division, but there is a problem here. So you will lose the, what we are trying to do here, we will do x divided by 7. 4 divided by 7. The result will be wrong because 4 is an integer, 4 is an integer, divided by 7 is also integer. It should give a point something, point something here. The decimal will be skipped, 0 point something we have to get, like for 0.56 something. It should give something like this, but since it returns an integer, since the logic function returns an integer, this will be skipped and we'll only get the 0 as the value, because integer divided by integer will always give a integer. So this is a wrong result. So how can we get the correct result for that fashion? So also one more thing, what if we specify greater than or less than sign here? What will be the result for this? What will be the result for this? It is not a bitwise, it is less than operator. It is less than and greater than operator. We are checking whether 4 is less than 7. Sorry, we are checking whether 4 is greater than 7, because first parameter, first underscore is 4, second underscore is 7. We are checking whether 4 is greater than 7. Right, that function, if it is greater than, it returns a boolean. It returns a boolean true or false. This method, obviously, yeah, that's right, it should give an error. It should give an error because we have defined a function to return an integer. We cannot return a boolean from this function. So it will say type mismatch error, saying found boolean, we had to add a integer as the return value. So how can we come over this? How can we solve this problem? So already we have achieved a lot of shortcuts. We will use some kind of a generics for these things. We have learned the type parameters. We can use the type parameters in this case. I will redefine the function here again, and I will say a comma b, x is of the type a, y is also of the type a, this also takes a, but the here, because we want different return data type, we will have a b here, because we want to expect different data type, return data type. So I define the function to be a generic function here, generic higher order function. So when we define our function to be very generic, now what we'll do is we have to specify what is the data type here in this case. We cannot just call without passing the data type. I have to say the first is integer and the boolean. So in this case we are saying B is boolean. B is boolean here. Similarly, if I want the actual result, I can say double comma double, and I will say 4.0, 7.0. It should give the result as, okay, division operator. Just use the double. This time it should give 0.57 some result. So this is how we make our higher order function a bit generic here, a bit generic. Any questions here? I hope the things are clear how to make a, okay. What's the question, Ram? Oh, no questions. Okay, I thought things were not clear. How about others? Any questions, or are we clear on the concept of higher order functions? Okay. Yeah, example for returning a function from a function. Yeah, as asked by uh, Sharat, what we'll do is I will define a function. I will take x, some input integer. I will say uh, function 1. Just give a name as function 1. And what I will do here is inside this I will try to give a function object. Let's say val x, val my doubler, or how do I say that? Okay. So I will, fine. I will say, yeah, integer is fine. I will check if x equal to 1 or 2. If x equal to 2, what I will do here is I will say val my doubler equal to whatever parameter we pass. I will define a function which will double the result and give the value. It will take this as a parameter equal to x of the type integer, and it should just say x star 2. Else I will say okay, I will try to do that later, but just say I define this function x is of the type integer x star 2 is fine. I will just say my double here. The if and else condition, okay, sorry, my mistake. So that's because I'm trying to give the same name. I'll just say double my doubler here. So this function returns a my doubler here. We have defined a function here, function object. We are returning that function object. If you see the return data type here, the return data type itself is automatically said that it takes a function and returns a, it takes some data type, input data type, and returns a function, and it returns a function here. To Let's not confuse here, the data types are not same. I will rewrite this function. I will rewrite this function. I will say my doubler. I will say a here and a star. This is how I will write it. I'll say my doubler. I will return that, because whatever is the last expression in the body of the function, that function will be written. Now I can call this val doubler. I will just say val doubler equal to, I will pass the function, I will pass some parameter. That parameter I was supposed to use to do some if condition. This time I am just calling this function. It will return a function doubler. It will return the function doubler. So I can use this doubler now, and I can pass some value and it will double and give it the result. So the best way to say this is, I will rewrite the doubler function with using that parameter. If x equal to 2, then I will say val my doubler equal to a as an integer, and it takes and it returns a star 2, and I will say my doubler. Assure Naresh. Else I will say, else I will return my tripler. Val my tripler equal to, it will take some b as a parameter, and it returns b star 3. B star 3 here, my tripler. So either it will, okay, why the spelling mistakes? Doubler, and make it as doubler spelling mistake. Just return, let me check, doubler, that's right. Again I made the mistake here. Sorry for that. I just copy these things, write it in some, change everything here. If this is the case, my doubler, else I'm saying val my tripler. I hope the things are correct now. So if it is value is 2, if x value is true, I will return a doubler function. If it is not, I will return a tripler function. I'll just copy this and paste it here. I should get the result. If you say it takes an integer and returns a function, and that function takes an integer and again returns a integer. That function takes an integer and returns an integer, because it will just double it and give the result, or it will triple it and give the result. I will say val doubler this time equal to function 1, I will pass 2. So it will double it and give it. The function that is returned is a function which will double it and give it. But if I can also say tripler here, and I can pass any value. Other than 2, if I pass any value, it returns a tripler function. Tripler function, I can pass anything and it will triple it and give it the result. Triple it and give it the result. 5 3s are 15, we got the result. So what's the question here? So the end result will be return value of the final function always. Wherever you are using this function, wherever you are using this function, that will be the final return value. That's true. So this is how we return a function from a function. Even these things are called as higher order function. But the most important thing is passing a parameter as a function. The third point is very important rather than the fourth point, because we have lot of use cases associated with the third point. We will have a lot of functions. Already Scala has lot of such functions, and also Spark also has lot of such functions. So we will end it here. We will continue again tomorrow at the same time. Any questions still here? Any questions till here? No questions. I hope the things were clear. Going forward, we will be using more and more underscores. It will be the only underscores. If you see, the very first time when we used underscore in the pattern matching, it was for default use case. Similarly, I also said that if you want to import all the classes in a package, we have to say package dot underscore. Similarly, we have used underscore here as a placeholder for the parameters being passed for the higher order function. So based on where an underscore is being used, the meaning of that or the definition of that underscore differs. And going forward, we'll be using lot of higher order functions. There are a lot of higher order functions. I hope the things were clear. If you have any questions, just send me a mail or message me. I should be able to answer the questions. If I don't know the answers, I will try myself. Probably it may take some time, and by that time I should be able to answer that. Sure. Yeah. Okay. Let's meet tomorrow, and everybody have a nice day and good night for some people. I think Harsha, good night. Naresh already left. Sandeep. Okay, Sandeep missed the class. Sandeep and Raj missed the class. Yeah. See you everybody. Bye. Bye and have a nice day.